Hello and welcome back. We are continuing with our playlist on Numpy. Today we are going to discuss comparisons, masking, and Boolean logic and how it relates to Numpy arrays. So first thing first, we import the libraries and we initialize an array, a single dimensional array, one dimensional array. My x is 1, 2, 3, 4, 5, 5 elements. If I do this operation, which is smaller than, so x is smaller than 3, what will happen? Like all the operators of a scalar and an array, if you all the mathematical operation we have seen, that it gets element wise done. This is no different. This less than 3 gets implemented on x element wise. So the first thing is evaluated, that 1 less than 3, true. 2 less than 3, true. 3 less than 3, false. 3 is equal. 4, false. 5, false. So what is the result of this particular operation? The result of this particular operation is a Boolean array. This is called a Boolean array. Why it is called Boolean array? Because all the elements of this are Booleans, right? True and false. True or false are called Booleans. So when we execute these type of greater than, smaller than logical operations, then what happens? Logical comparisons. Then we get result as a Boolean array. Similarly, x greater than 3. Again, same logic. Implemented element wise and resulted in the Boolean array. Okay. Same. Less than equal to, greater than equal to. All the logical operations, right? Comparisons which you see. X not equal to 3. All the only this will be false where x is equal to 3. It's equal to 3, the opposite of that. You can also employ these complex type things. That what will be the result of this? 2 star x, all the elements multiplied by 2 and all the elements exponentiated by 2, and then we are trying to find the equality, like whether they are same or different, right? Element wise comparison. What is happening? I'm resulting into a, because everything will be compared element wise. This is multiplied element wise, exponentiated element wise, squared element wise, and then compared element wise. I'm resulting with a Boolean array, right? So these are the your operators, and these are their NumPy equivalents. You can use mathematical operators or NumPy equivalents also, both the same things, right? Okay, and you get this Boolean array. Okay, now why this Boolean array is important, right? What is so big deal about Boolean array? Well, but before that, let's try to understand. We are only seeing the examples of one dimension, but it works in multi dimensions also, and we can see it over here. Let me create an array x, two-dimensional. I initialize it. X less than 6. All elements of this will be executed this conditional logic, right? X less than 6, and then I will get a Boolean array of the same shape wherever it is true or false, same like one dimensional. Okay, I executed it. Now what's the big deal about Boolean array? Okay, now let me print the x I have printed. Let me include this Boolean array inside the sum. Okay, inside the sum. So I'm doing the np.sum of this Boolean array. And what was x less than 6? Let me show you. X less than 6. X less than 6 is a Boolean array like this. If I do a np.sum of this, what will be the answer? The answer to that is 6. Why it is coming 6 over here? Because true is executed as 1, false is executed as 0. There are 6 trues over here, so the sum is 6. Okay, clear? Now let's see that how we can make use of it. Okay, so we are doing a sum, and we have, let's say we have a two-dimensional array or multi-dimensional array, and along the axis we want to find how many times that is true. What we can do is we can provide x less than 6, axis is equal to 1. Axis is equal to 1 means row wise we are doing. Axis is equal to 0, column wise we are doing. Remember, axis 0 is column wise, axis 1 is row wise. So we are doing row wise. Now this particular my Boolean array, I'm doing a sum axis wise. That means how many truths are here? 4. How many truths are here? 2. How many truths are here? 0. So 4, 2, 0. This is very handy in, think about a term that we have a tabular data, right? in an Excel sheet or something, you have a tabular data, and then all those columns you want to see that where all, let's say this condition is meeting as true and all, right? If you have to do these type of analysis, this particular comparison and the Boolean array comes very handy. Are there any values greater than 8? So the other function which Numpy provides is any. Okay, the way any works is if any one of them is true, it will return true. So is any value greater than 8? Are there any value which is greater than 8? Obviously there is a value greater than 8. Why? Because if you see x, yeah, this is x, there are 9, 10, 11. So there are values which are greater than x. NP any value which is less than 0, there are none values, so it will return false. All is like any was any value, all is all the values, then it will return true or false, right? What it means is that are all the values less than 10? False. Are all the values equal to 6? False. Are all the values less than 100? This will return true, right? Everything is less than 100 over there. So np.all and np.any also can be used to make these complex logics, right? When you are doing your data analysis or EDA work, right? np.all can also be executed along column wise. So when we are doing the row wise, you can do this row wise also all. Okay. Boolean array as masks. Now, what is Boolean array as mask? Like, how can we do the masking? Masking is what? Masking is suppressing, right? Masking is hiding, suppressing. So how we can do that? X is this. X less than 5 is a Boolean array. No problem with that. When we supply this inside of the array, this is my Boolean array, right? And this is my actual array. If I supply it inside this, what I will get? I will get all the values. Okay, we can simply index on the Boolean array. This is known as masking operation. So what I'm going to get over here, I'm going to get 0, 1, 2, 3, 4, all the values which were less than 5, right? Basically wherever true is appearing, it will just give me the output of those. Clear? Okay. Okay, now let's try to see this, and we have seen it in one dimension. It returns the one-dimensional array. Now we are let's try to see it another example. Okay, and what we are doing over here, there is treat this as like each row is a student, each row is a student, each column is the subjects, right? So these are the marks obtained by 10 students in 5 subjects, right? 10 cross 5. So these are students, this is subjects, right? Okay, now let's run this, and I'm assigning something. Okay, so if I have to say that who are the students who have failed and in which subject, what I can do a masking, right? Less than 40 is fail, so I'll do a masking, and I created an array which is, so all the places where true is appearing, those are the subjects in that a student has failed, right? Those who got A grade, right, greater than 90, I can again do the masking. What about the rest of the students? So I can do an ampersand, and what I will do is that average student, I will create a Boolean array of average students, those who have passed greater than 40 but have a scored less than, not a scored A grade. They were average students, right? What I will do, I'll create a Boolean mask of average students, right? Then suppose I'm just trying to show you an example in what all ways you can use these Boolean arrays and masking techniques, right? Suppose somebody asks you to, okay, get me the mean score of average students. I can do easily because I have a masked array, right? I have a Boolean array, sorry. I have a Boolean array. I can calculate the mean of that, and you can easily give me that. Okay. So this is how you make use of Boolean arrays, masking techniques, comparisons to do complex data analysis work in Numpy also. With that being said, I will close this video at this time, and I'll see you all in the next video. Bye.